Hi, Sportster Paul here. We're doing BobCAD CAM for SolidWorks. We're going to do some 3D stuff. We're going to make a whole part. Might be interesting. Other shows I was saying, what a great price for 3D. Well, that's for basic 3D. If you look at what is offered, I got a new quote, and it's like a mid-range package where it's around 5,000 to get all the 3D. When I install the demo program, it shows you what you actually get in the demo. And that is 3-axis premium. So when I asked about that, I'm not going to play with the 5-axis, or the lathe, or the mill turn. Simulation, I want the pro simulation, and I'm not sure what the difference is. You can figure that out. And edit DNC, I want the pro stuff for that. So it ended up, pushing up to comparable with the base package of SolidCAM, but SolidCAM only comes with 2 3D toolpaths in the base, constant Z level rather, and then planar, I think, or a level one. So that's that. Let's get up to SolidWorks. Here's this kind of goofy part. It's a part I use in my redesigned motorcycle I'm working on, oil reservoir. And what I did is I took it and I put on the extrusion, I put a 10-degree slope, so that there's a nice slope surface for all these good 3D toolpaths, which broke out all of these holes, but I figured let's leave those and just see. And sure enough, like any program that's trying to automatically help you with anything, it screws up BobCAD. It doesn't quite realize. It won't deal with counter bores when they're partial like this. So we'll go around that. Let's see, what are we going to start with? My thinking... First, we'll go over to the SolidWorks tab. We'll go New Job. This is all okay. And Solid Body, what are you going to make? This thing. Stock, I noticed you can set the material right away. And it's got a pretty nice dialog box here. We want wrought 6061. And this might be a mistake because 6061, and even 1.5 inches thick, is rolled in a rolling mill. And there's a lot of stress in the top and the bottom, and when you carve that off, the part can tweak. If not 6061, there's like cast alloy and various cast aluminum things made for mold making and stuff like that that don't tweak but they don't have the properties of 6061. Not that an oil reservoir needs any kind of super properties. So let's go stock wizard. I have all kinds of problems with this. So we're going to do the outside first. One of the problems I found with BobCAD is it won't let you move setups around. You can't just drag stuff. It's like it was designed before drag and drop, before Macintosh. So you can create a new setup and then copy, paste, but then it loses all the geometry. It got to be quite clumsy. And that came about because at first I was doing the underside, this hollow part, and then the top. Now I've changed it around. We'll see if you folks agree this is the right way to do it. Bounding box. This is given the sides of the box, but you don't order stock like this. I'm going to order stock 8.5, enter, by 8.5, 8.5, enter. And I'll order plate that's 1.5 inches thick. Now here's a goofy thing. It puts, let's get the icon. There's a fancy name for that. What is that? What are we trying to do? This thing. Unfortunately, this can get tricky. See, the only linear thing that lined up happened to be, these edges here. So if I go like that, puts Y along the right way, then here, see, this is where stuff starts going bad. Edge 1, and then I got to do Z flip, and everything goes back to normal. It freaks me out. I just don't know why getting a part 0 can be so darn complicated, right? Just leave stuff alone. And this is all the programs, right? I'm not pleased with any of them. Okay, but it's flush here on the top, and we want a little meat. Now, I had a 1/10, but you'll see why I've decided to just put 50 thousandths on the top. When I hit enter, you'll see it jump up. See it jump, but the bottom didn't jump up. It's very confusing. So now the stock is 1.55. So you got to go here and make this 1.45. Enter, and you see it jump up. Now it's 1.5 inch stock with the part positioned where we want it. I don't put the part 0. Well, you can't right now. Just get it oriented. I figure orient the stock with the machine the way it's going to be in the machine. Machine setup 1, let's rename it. You didn't see it at the bottom of that dialog box. And this is the outer setup. We're doing the outside of the part. Outer setup, no fixturing. So let's do mill facing. We're going to face this. I used to just do a pocket so I didn't have to face all the material. Don't pick any geometry because you want it to do material approach. Let's figure it smart enough to figure this out. Machine strategy, just facing. That's cool. Posting we don't care about. Rough. It's a 1/2-inch tool. I don't have 1/2-inch tools. Let's use a rough end mill. And I always have trouble with this dialog, what it's doing to me. I want a 3/8-inch end mill. Okay. There it is. And you'd think, okay, we're not using the flat. Well, see, it thinks it's still using it, even though it's not. Then you go here, but I don't have a 4 flute, and I can't find a way to change it from high-speed steel. So that's kind of annoying. It has to be longer. It has to be let's make it 1.5. And the overall length will be at least 3 inches. And the protrusion out of the collet will be 2.5. So 3/8. I did learn you set the units in the in the SolidWorks option document units. Put 4 units, and then you see all the 4 here. Otherwise, it'll pick up from SolidWorks. You'll just have 2 units, 2 significant digits. I think we're okay here. Next, patterns. We want to do adaptive because I want it pretty, right? Because this is the outside of the part. And adaptive's a really cool thing that they offer. I don't think any allowance. Was there anything in patterns? I don't think so. Lead in. I'll pull it off here and hit compute. We should see it do its thing. It's got to think. It's a complicated toolpath, so this dialog comes up. And there it is. And the reason I'm machining all of this stock is when I flip it over, I want the part and the stock to be flat on the table. Before I was pocketing this out, and you'll see why that's going to be a problem. When I break the part out, it'll fall 50 thousandths, which might just tilt it and gum up the gasket surface we're going to be doing. But this is cool, right? We're happy. So we can go click, click, wait, click. Oh, I'm on the stock. That's what's going on. So we've blanked the toolpath, so we don't got to worry about it. So we've faced it. The next thing I figure, well, I don't want to rough this in the classic sense of removing all of that stock, right? That'll be a waste. So let's just cut a perimeter around this thing, 2D perimeter. Let's see, insert mill 2-axis, select a geometry, flip around in AutoCAD. SolidWorks keeps helping you with select tangency. See, it's done blue all the way around. You say good. You do next. I think, well, let's make sure it knows what it's doing. I found this always can benefit. Won't pick faces, but pick the bottom. We want to go down to this level. I think it had it right, 1.3 something. No. Okay, so now it's right. So, next, do I want to do a rough profile for this? I don't think so. I think we can take the rough profile off. Just do profile finish. We'll find out. This can turn me around. See, it's showing, it eliminated the finish and rough over here, and now it's just finish. This is showing if you want to add tabs around, which I'll show you later, but we don't, this operation. Next, posting, we don't care about finish. Okay, wrong tool, tool crib. Flat end mill, 2 flutes. Well, now will it let us delete this stupid thing? Are you sure you want to delete this tool? Yeah, okay. So here's the 2 flute, hopefully longer, flat bottom end mill. Yeah, it's the longer one. Flood coolant, that's cool. Next. I think this is just a standard system comp left. That would probably go wrong. No side allowances. We do want multiple steps. Let's go down 1, 2, 5. And then if you go like this, back up, it's 11 cuts it's going to take. Next, leads, I think a vertical lead. I want to come down on it because really I'm doing a slot here, right? Corner types, all this stuff's cool. Compute. Notice it put the toolpath inside, because just like MasterCam makes it obvious, not really that obvious, that there's a direction, here I've learned you go default chain and say reverse direction. See that little arrow there changed? So now when you're on the left and it's going in this direction, you will be climb milling and being on the outside of the part. You can go up here and say compute all toolpaths, and there they are. Nothing on the inside, right? Happy days. So down here, I can't see it. I'm saying rename. What is this? Perimeter. Enter. I think you can just do this and this. Okay. So now we've got the perimeter done. So there's a big wide gap all the way around this part, but not all the way down, right? There's still going to be, I think, 150.150 down here at the bottom, holding this cutout part to the stock, which I assume you'll have toe clamped or bolted down to your table. Next, we're going to do a finish. It's a 3D. I may have to refer to the part that's already done. I thought I'd do it. No. Insert 3-axis. Select the geometry. I think I said just select the whole thing. I think. Like I say, we may have to backtrack, or I'll skip ahead. Next, feature, top of feature. The top is going to be here. Just in case. Yeah, I changed it a little. Next, it's not roughing, because roughing would do this, right? It would carve out everything. It's Z-level finish. The roughing we can get rid of. Took me a long time to figure out what they were doing here. And then when we click, you'll see this stuff get the right way, right? How do we do this? Up here, click here. There, now it's got itself. Z-level finish. I'm pretty sure this is the right way to do it. Work offset 1. Oh, I got to fix that. Rough. Now we're going to go tool crib. We're going to go end mills finish. We're going to add from tool library a ball end mill, 1/4-inch ball now. Okay. It shows up here. It just seems like a lot of work to get a tool. Okay, so it's a 1/4-inch. It's got the right ball. I want it deeper because it's going to be cutting deep. So I think 1.25 is what I've been doing. While we're here, let's make it 3 inches long. Protrusion 2. That work? Yeah, I think that'll work. 2 flutes. Did I get that? Tool number 2. That's smart. See, and I get confused when I go back to tool crib. I'm not even going to do it. Let's just keep moving. Patterns. Climb mill. That's all the choice it's given us. Next. Depth of cut. I want 02. I want fine cuts. No allowances. These are the tolerances. 5/10 is enough. And this was the secret. Top of job. Give it some help. The top of job is here. Bottom of job. And this is what was tricky. Pick. So you pick here, but see that ball mill, that means the tip of the ball mill will stop in this plane, and you won't get the very bottom. Trust me, I spent, a half an hour trying to figure it out. So the bottom of the job isn't 0. It is minus 125, right? Half the diameter of that 1/4-inch ball mill, so when you put the tip of that all down 125, the edge of that ball mill will go all the way down on that surface. Kind of hard to follow, but you'll see. Next, leads, plunge, I think. I just come down on it. Options. Let's see. We only want to do the outside because it will do the inside. I couldn't figure it out on the one undercut show. Maybe I'll go back to that on my own. Compute. Let's see what it does. It's a complicated toolpath. It's got to think a lot. I tried advanced. I tried rough first, and you see it hogging the entire stock block away. No, I don't want that. I tried Z-level, couldn't get it low enough, and I went back to advanced, finish, thinking advanced. I think that's what the premium 3D package gets you, those advanced toolpaths, which are cool. They got things like 3D extents. We used those in one of the shows when we were making our test part. My buddy Dave Rui, the mechanical engineer, industrial designer, machinist, does it all. Made that one test part just to confound CAM systems. Because our step over is so low, it's taken a long time. But I practiced this enough. See how it went underneath? And that's why I only did 50 thousandths extra stock on top and 150 on the bottom. Because you can do the math, it's 25 thousandths material. We haven't cut this out. Right? They're still going to be, even though the ball's down 125, it's still going to let us do our thing. So, let's see. Edit. No, rename. Sorry, you can't see that. These are the sides. Except I like to capitalize. Sides. And I think you can just go like this and like this. Tuck that up. Let's do let's do a file save. No, not save as. File save. It's telling you the Toolpaths will only show up in another demo mode BobCAD. If you have a paid for BobCAD, the part can open, but you won't see any of the Toolpaths. You won't see this job. All right. So now what did I find? You go a fixture in the purple. Oh, it doesn't matter. Their simulator is a ModuleWorks simulator that plugs in, which I am not thrilled by. MasterCAM uses it, right? The expensive package and the cheap package both use the same ModuleWorks. And ModuleWorks does most of the visibility off. And we make it pretty fast and run. So here it's doing that adaptive facing. There is the perimeter. 3/8 inch end mill. My gantry mill will take a 1/2 inch collet. And here it's going down. Oh, now I get to show you something. I can stop this. I learned stop it before you quit. All of the programs. What I forgot to know is it's trying to do those. Where are we? Sides. I've learned you can just do that. See, it's doing these and doing that, and it's trying to go inside and doing all kinds of goofy stuff. This is why you want your program to work in SolidWorks, because this would be a major. If you just got an IGEAS of this on a standalone MasterCAM or a standalone BobCAD or a standalone anything, one CNC, you got a heck of a trouble trying to pave this over. So the Toolpaths with SolidWorks, you take the bar, you drag it up over the bolt counter bores, you go back here. I don't know what to do here. I just say no, right? Sides, compute all Toolpaths, and I'm sorry, it's going to take that while. There's so much to remember. And this time, I didn't want to just go through the part already made. I've done that like the last show, and it's just not as satisfying as watching me struggle and suffer. And go look at them and notice, now they're just following the surface the way it is. To me, that's worth it. I had the SolidCAM guy who doesn't have a standalone package. The sales guy, he's like, well, some companies like a cheap little computer out on the shop floor that runs MasterCAM standalone, and then you got to use MasterCAM's CAD, which I hate. Visual Mills CAD, the standalone, I hate. Now you're in SolidWorks. Look at how beautiful. Okay, so back, I say no, don't do anything. Don't help me, please. So that's the outer setup. Now I think you got to go up here. You say, oh, promising what I don't deliver. I should have saved it, but I didn't. Let's hope it's stable. I've had a couple crashes, always doing something goofy, like having the simulator run and then crash out of it. And now let's just go fast forward. And let's go visibility. There, it's done. Visibility, oops. God, it's so clumsy. And now you can see, because we defined that depth and added a little to the depth, now this corner of the ball mill gets down to this black line, which is the part. And then the tip of the ball mill, going down 125 extra, goes here. But I've left enough material, if I section this, you'd be able to see there's still 25 thousandths holding this part to here. And like I said, I used to just pocket this and flip it up. But I was afraid when I cut the gasket surface last thing, when the part falls, if it falls one way, then it's going to damage the gasket surface. Worst place you'd want to do it. So let's get out of here. Do what we forgot, which is file. Save. Yes, we know it's demo mode. Thank you. Now we go milling job. add a setup. I like the way they just pop a new setup. Rename machine setup. This is going to be inner setup here. I'll look at outer setup, inner setup. I can't remember if we on this outer setup. Let's edit it. No, I didn't put the part 0 in the right spot. Good gosh. Origin here. No wonder it was so goofy. And same problem, but now see, you can say y-axis and pick the stock, and then flip it, and then flip the z, there it is. So that's why it was giving me goofy numbers about depths and that, because the part 0 was down here. I want to find this top corner on the stock. So you say, okay, great. Now we're going to go back and drain this one. This is why I like doing it real time. It can show you all the goofy things you got to deal with. Okay, so now we're going to flip it around in the vise like this. And see, part 0 isn't on the stock anymore. I wonder if we can do this. Because we've faced this stock off. I'm thinking, what if we chose, well, no, you can't do that. You got to find this. Well, it's got to be up here, and I'm going to have to do part 0 up there as well. I'm going to have to change that part 0. 1, flip it, and flip Y, and then flip Z. There we go. Ignore all this part 0 stuff I'm suffering with, okay? Because, see, setting the part 0 to the corner of the stock both times means the thickness of the stock will change the thickness of the part. Can't have that. So I gotta, well, let's do it now while we're fresh in our minds. Edit this. So, see, our part 0 was here before. So if we put it on that exact same spot, here, and it kept, that's going to be a little harder to find that corner, and it's on the movable jaw of the vise, which I'm not thrilled about, but it's the same physical point. Now the part, because the stock variance won't matter, right? So you're not finding the top corner in the back, you're finding the bottom corner in the front. Not quite cool guy stuff, but hopefully it's all going to work out. Next, say okay. Inner setup. Okay, it's nice. One of the things I hate about the simulator is it uses different mouse buttons to navigate, to rotate and pan. I like the pan function better than control middle button like SolidWorks, but still. Now, how did I start this? Did I face it? No. I roughed the inner. I'm going to come back and do these holes, but I figure it's a 3D show. Let's stick with the 3D. Mill 3 axis. I think I just can select, I'm sorry, go here, clear the selection, select the whole part. I think I got away with this. So we got the geometry selected. Next, all this stuff hopefully is correct. Here's the strategy. Z level rough, but we don't want to do planar afterwards. Z level rough, okay? Next. Don't care about this. The roughing, it's that same mill. Pocket in, pocket out. Might be pocket out better. Parameters. It's going to go tenths. Let's go 2/10, just so there's fewer tool paths. No allowances. Let's cut it true. Cut holes. Depth options. This has always helped me. Every time I use this to help define things, the bottom of the job pick, first time I saw this, go just pick how deep. That was visual mill. Leads, okay, options. This you got to do inner only. Otherwise, it'll go and try to do the backside. And I think we can go compute. It's going to think, and we should see it roughing out the inside. It's fairly complicated, right? It's got solids. There we go, right? It hasn't climbed up on this surface like It might if we let it go nuts, right? Hasn't done all the stock. And let's just be happy with that path. Okay, so here, now you can see it. Rename. This is inner rough. Okay, good. Do we hide everything? What was that? Oh, I changed all the toolpaths when I changed the origin. Compute toolpaths. Compute all toolpaths. Good thing we checked. Compute all toolpaths. This is where we should see this disappear. Where are we? Compute all toolpaths. Yeah, we know about that. That's just a warning that you're sending the tool below the part. Oh, but now we've unsuppressed the things. See, I wanted to do all these mistakes. I'm sorry if this is, exasperating to you folks, but I've been going through this for 2 days trying to figure out a good way to do this part. And it's always like this back and forth. It's like I read a book once about writing, right? Because I'm a professional technical writer. It said they shouldn't call it writing. They should call it editing. Because what you're constantly doing is rereading and rewriting and rechanging and fixing all the screw ups. So this is a complicated toolpath, so it's right. The perimeter, didn't I say compute all toolpaths? Okay, let's blank everything. Is this unblank toolpath? Okay, something's wrong. We did say, come on, darn it. Compute the toolpath. It doesn't want to change. Geometry. Reselect. Let's do this. Let's do clear selections. Select tangency. Thank you, SolidWorks. Go OK. Perimeter. Compute all toolpaths. It's done it on the wrong side because this is software. Reverse direction. Perimeter. Compute all toolpaths. Did I say update geometries? I'm not sure. Okay, now this part's looking right. Sorry to be a space case. It's half hour already. Okay, inner rough. We got the inner rough. Now we want to do these radiuses. This was a little tricky. Some of the things that took some time. It was select the geometry. Here. At first, all we're trying to do is round this off down at the bottom, put this fillet in, because even though it's on the inside of this oil reservoir, I'll know it's there, and I want the part made to print, right? I assume you will too. So at first, I just did the fillets like this all the way around, and the tool would go gouge the heck out of it because it would put the tip of the tool on the edge of this. So by going up here, it helps this thing know that we don't want it to treat the top edge of this fillet as the center of the tool, which is what it was doing. A little bit of time. And that's the other thing about this simulator. It was just something looked a little off. Well, why is there 2 lines in the gasket surface? What is those 2 lines? Well, that's because of the way they show the stock. And you start playing around suppressing stock, and you can finally figure out you left all this meat. Not as clean as SolidCAM. Oh, see, it left a couple off. Always good to kind of look, see. All right, so we're going to do these radiuses. So we say, okay, it's happy. Then next. I'm not so worried about here. I think it was just Z-level finish. So the rough can come off. The planer can come off. You go next. It's not rough. It's tool crib, finish end mill, our 2 flute. Why is there 2 of them? Why do they? Okay, so is this one unused? Yes. Okay, tool number 3 we don't want. but we do want this one. Okay, so there's our longer one, so the flutes don't touch the side as it's spinning. Next, climb mill, absolutely. Depth of cut, same thing. We want pretty fine. Let's do 20 thousandths. No allowance. It's a finish. Top of job, pick. Now this is where it gets cool. You pick that. Bottom of job, pick. I didn't do this once and it didn't hog it down quite right. Okay, next. Leads, just, I think plunge works. Options. Let's see, what are we? We're on the inside of this, right? Just do the inside. It tries to help and do both sides of the surface. I think we can compute. This is going to be another thoughtful one where it's going to take a while. And if I did it right, which may or may not be true, we'll see. We shall see. Yes, I did it right. So that kind of concludes the 3D. I'm going to come back and show you how to do these holes just so we have a finished part, right? That'll be cool. But meanwhile, click, hide everything. Do a file save because when it did have this thing crashing on the fixture show, it crashed going into the simulator. So just in case, and I should tell you, window, does this work yet? Not yet. The simulator's got to do its thing. Does a lot of thinking. Oil reservoir, BobCAD, solid part. Okay. So visibility, hide those darn tool paths. Just go to the finish so you can see what's going on. And well, actually, see, old collisions, I didn't do the work offsets. Come on. It shouldn't be breaking out here. I'm a little confused. Maybe that perimeter I didn't do right. All right. Like I say, I like showing all the grief. No, perimeter just comes down to the right spot. The sides, I didn't change that. Z-level finish. Oh, that's what's wrong. If it wasn't for the simulator. Now I'm worried I got them all screwed up. Okay, edit the Z-level finish. What is it? Patterns. Where do you say parameters? Pick the top of the job. What are we doing? Is this the outside? I think we're going here. Yes. Pick the bottom of the job here. Yes. And then this is where I said 275, I guess, would be 275. Right? Now compute. And okay, we know about this. This is no worry. It's just saying, wait a minute. We know where the part ends in physical space, and you're driving this tool below that. When I put that negative number. There's a lot of back and forth. And of course, when I designed the part real time, all the different tool paths, all the different operations, all the different back and forth, there was a lot of back and forth. Oh, and I'm screwed up again. Cancel it. Outside fillet. Now go back here. No. And where are we? Not perimeter, sides. Compute all tool paths. No, that was just saying you want to change something. I've learned all the ways this can screw you. Compute, excuse my language, compute all tool paths. No, don't do anything. Just do your thing. I'm not going to go and change. That's what it's asking you. Yes, okay, now go change the numbers. They don't tell you that they expect you to go change the numbers. It's just, yeah, okay, we're not going to do anything now because you said the word yes. And let's look at them. And did I go in the wrong direction? I must have. Z-level finish. Well, let's see if I can edit directly. Parameters. Wait a minute. Pick here. you can see I changed in part zeros. What do I want to do? I want to go down 125, so I think that leaves 025 is the number we're trying for, okay? And we say compute, and no, don't stop doing stuff for me. 30, actually we're not too bad a shape, 35 minutes. It'll take a while to put these holes in. So you can tune out after we get this guy right. Oh, and we got to go look at it, Z level finish. Now it's doing what we want. You know, going 125 below the level of the part. Up here, turn everything on, turn everything off. File, save. Yeah, we know it's a demo. Simulator. You get a rhythm, you know, it's like playing in a drum circle with a bunch of hippies. Visibility every single time. They must figure, well, he wants to decide every single time. Toolpath, just run this out. I kind of know what I'm looking for, you know, because of all the problems I found figuring this out. Like I said, advanced rough. Okay, now it's acting the way I want. It leaves this ball. This corner here is the edge, like before. Let's look at what we did to ourselves here. Okay. It is not, however, I'm not sure what it's doing. Z level finish. Okay. Let's get out of this and see what we did to ourselves. Oh, duh. Okay, our toolpaths are there. I guess it was hogged out underneath. Although you think everything would have worked anyway. Let me look. Go back to BobCAD. No, don't do anything. Inner rough. Is that all dialed in? Yep. Okay. Once again, file, save. I'm kind of glad you're seeing me flail, so that way you won't feel so bad when you flail around with all this 3D, with all these programs, right? I like the ease of use of Visual Mill, but then they kind of complicate things when you get their dialog box up. There's these 2 rows of tabs the way Microsoft does. God, I hate it. So you pick one of the upper, then everything moves down, and then they change. Sometimes advanced cut parameters is here, sometimes it's over there. Every time, no toolpath visibility, fast forward. Oh, by the way, you can see down here, this slider is telling you how far it's doing its thing. We got all these table collisions. I'll show you how to fix that next. And now it's the way we want on the, oops, too far, on the inside, right? Monotonic coming off of this flat, coming up here. All of this is math errors or rounding errors in the Modular Works module. Let's get out of it. Let's fix our outer setup. Oh, see, because I'm used to the simulator, I start using my right hand to try to rotate my left finger to try to rotate stuff. Outer setup. It is down here. Edit. It's saying it's crashing into the table. And so you got to raise the thing up off of the table. Why it jumps to that number, I don't know. Let's go a ½ an inch up here. Then the inner setup. Now we got to go up, edit, work offset of at least 1.6 to get it up off of the table. I'll show you. There's a video actually. Enough people have trouble with this kind of crashing into the table. What table? There is no table. Well, you're not looking at the right simulator view. Let me think. Save. Yes, save everything. Let's see if we fixed anything. Simulate. See, I don't like to see the part workpiece moving around, but they're all proud of their machine simulation, which you get to, where is it? Here. So you go here, and there's the machine.
And now if I did things right, see, because I did a 1/2 inch, we're up off. Of course, they're different. I should have made it 1/10 of an inch up because I think the other one is going to end up 1/10 of an inch. So that's kind of scary. But getting this workpiece, otherwise they put the part 0 flush with this surface here of the tool table. But we don't like looking at that. Let's see if over here any more crashes come. Probably will be. There was always one when I left the part, something in the roughing. Here, stock and tool. In the Z level rough. And that's going to take forever to go real slow and see where it pops up. I'll do that on my time. But, oh yeah, see why I disabled the toolpath. So, that's that. So now, you tune out now if you had enough 3D. We're 40 minutes into this, but I did learn, don't show me the stock. See, I'm using the wrong buttons because the simulator uses different mouse controls. Why would they do that to their fellow human beings? All right, so, oh no, we're not actually quite done yet. I haven't cut the part free, have I? Inner setup, outer setup, stock, close that up. So here, where do we go? Z level finish. God, I get so, they're little flyouts. Programmers, don't you love it? Insert mill 2-axis. Select the geometry. We want to cut the perimeter of this part. And say select tangency. It's gone all the way around. We say fine. We go here and pick top. Let's pick the top. Well, I don't know where the top is. It's top of the stock. Let's hope that's right. Pick bottom. Here. Let's see if it changes. No. Okay. So this thing's pretty smart. Of course, that's where the geometry was. Next, what we want to do is profile rough because we're going to need to make several passes. Next. It's using that end mill we want. Patterns. Now you got to know to go side roughing. Step over. Take 3 passes. Oh, there's something you're going to get a kick out of. And I think here I said, well, step over 250. Zig, yeah. Left, yeah. Machine compensation. We'll figure we're starting to understand all the goofiness here. No side allowance. It's a roughing operation. They always want to leave stock. Let me think. No, it'll be okay a single step, I think. Entries. Usually by the time you get down here, you just say compute. And it's actually done it on the right side this time. But watch, it might leave a little sliver of material right here. This is going to be entertaining. But you can see as it comes out, as soon as it gets to this edge, now the trick, after you rename this to gasket surface, bang, and edit it. And I think patterns or parameters. The side allowance. If you have a positive side allowance, it leaves stock. If you do a negative, minus, 0.375. Let's try that. Compute. See how it's gone out here? So now you're sure you're going to cut it free. It should cut free pretty quick, right? As soon as you go to this edge. But that might be a good way to do it. You can play around with that. So that's that. I can show you. Let me see. File. Save. I don't know why I get spaced out towards the end of the show. Simulate. And now it will be cut free on purpose, unlike that one problem area we had. Nothing works. You got to wait a while. Flash, 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 all this stuff. There. Oh, it remembered. Now it's thinking again. Okay, toolpath gone. Fast forward. And like I say, you should run it at speed at least once so you can be sure. And there might, you might want to do step overs here. The real machinists. I'm just learning this stuff. See how it left material here? That's worse than before. Okay, well. The 3D portion of the show is over. edit. First, did I use the right tool? Yes. The parameters. Oh, I did all this side allowance. Let's use a small negative side allowance. We only need to go 250. And where is this? Step overs. Let's do, it worked once. No, let's go back to the way it was. I hate to be spacey on you. I think I left 0.01 at one time. Do I want to do it this way? No, let's go 0. Sorry to be thinking real time on you. Patterns. Step over 3 passes. Now let's compute. There it is. Now. See, one of the problems is the simulator, it's all or nothing. At least I haven't found the way. No, you should have a stock in progress, and at some point, when I say simulate, all that's calculated, it's memorized, the way SolidCAM works. Fast forward. Come on. Oh, it's still thinking. I'm turning it there. Now we're done. I just lucked out, I think. See, because for a while, it was leaving a little slice of stock up here. And I had one that worked right, and then as I practiced a different, to practice this, how come it's leaving a little slice? Very ridiculous. It was default change start. Oh, see, just where I happened to click it, it's doing some kind of fast forwards. If the start point isn't here, it leaves a little sliver of material right here. So you could do smaller step overs and more of them to be sure to get everything. But I thought that was a cute. Oh, see, I'm using the wrong buttons again because I'm used to the master cam. Or I'm sorry, I'm used to the the BobCAD way of doing mouse controls inside the simulator. All right, blank, blank. What do we want to do now? Did I get on this outer setup, is that roughing sides? Yeah, so don't recalculate now or it'll put those holes in. So what did I want to do? We've faced it, we've done the perimeter. I figured right now, add a drill. Now I tried the counter bore, which is what these are, and it just gets confused. What worked out the best was add a drill, What's it want? Geometry. Flip this around. SolidCAM remembers how you pick them, and it does the machining in that order. I thought that was pretty civilized. At least I'm pretty sure it does. It seemed to work like that. MasterCAM, this program, they decide, although this program seems to have a more... Okay, so there you pick the 5 holes or whatever they are. Here they are. It's got the right diameter, 283. Pick the bottom. We don't want to go into our table, so let's go there. And BobCAD is smart. It knows the tip of the drill has to go a little further than this. So to them, depth is the same way SolidWorks does depth. The corner of the drill, where the tip starts, the cone of the tip starts. Next. I don't even know where I'm at. Feature, next. Strategies, here we are. Center drill. Then I want to drill. And then the only way I found to do it, you see, it won't let me select the counter boring tool. Because, oh, you're in the drilling, not the counter boring. Pretty exasperating. Maybe there's a way, I assume there's a way you could fool it. Just don't, but the simulator won't simulate properly. So now when I click it next, you'll see all these operations show up here instead of the center drill. Next, next, work offset, center drill. I don't like this big diameter center drill with a funny collet size, so I go here and I go center, oops, no, add from tool library, and there's a 1/4 inch diameter center drill here. I say okay, I say okay. Now it's got the same collet as the 1/4 inch ball mill. I say next. They only want to go 80 thousandths. I don't know why. I like 2/10. Goes a little deeper. Next. Okay, now we're in the drill. The drill's all cool. I thought, was there a way to do Peck here? Peck drilling. We'll leave its default. See, it's smart enough to know it's got to go down 144 to get this corner
down flat with the part. You can say, well, rather than that, let's go 50 thousandths more. Will I be into the table? I don't, well, not 50, if I go 1.5 overall depth. And watch this change. See? This is where it's a computer. Thanks for helping me. Then do next, excuse me, the boring mill. Don't use the system data. See, it's trying to make a bore the size of that hole. I happen to know those counter bores are 0.44. I know because of the counter bore thing. Then next, and then don't do this. And the effect, because it's a square bottom tool, you can go 0.5, enter. And since the tool doesn't have a tip, it's a boring tool. I don't know what this is. 1, 2, 3. Okay, good to know. Well, we're done. Compute. There they are. Then, let's see. So the feature is done after the perimeter, but what screwed me up, you got to go machining order and make sure it's doing stuff in there. See, it's doing the sides first, and I don't want that. So push the sides down under the holes. So now it's going to face the outside. It's going to do that deep cut. Then while it's all flat on the top, it'll do these holes. Then it'll do the ball mill on the sides and do all the breakouts and all that bad stuff. Now this is the bottom setup, inner rough. So it's trying to guess, but same tool, 3, 4, 5, and 2. So it really is kind of arbitrary as far as, I guess it's just saying, well, tool number 2, I'll do tool number 2 after tool number 1. So if I define these tools in the right order, I might not have had to do that. But since this is one of these feature things, the way CamWorks does it, you're always fighting file, save, the part's done. 50, it's going to be under an hour, so that's good. So, I'm getting so spaced out. Here. And with 8 minutes until a full hour show, we'll actually draw it. And I think there's going to be that one gouge or that one tool crash that I'll have to figure out on my own time. Don't look at the toolpaths. Keep it pretty darn fast. Let's go run. It's doing the facing. Next we're going to do that perimeter, real deep. Now it should be doing the holes. Bam, bam, bam. Now it's doing the sides. And you'll see, I think actually 5 half an inch down is not quite enough. And see, this is level, this area here is level, same, up here. That's all level with the bottom of the part, because that's how deep we had that perimeter cut go. So you'll see the tip of the ball mill gouge into that on purpose. That's what we want, so that the corner of the ball mill gets down to this corner here on the surface. Here we come there. See, it's starting to dig in. And we've got it. But we've left a little meat down here to hold everything together. It'd be interesting to see how flexible all this is when you pick it up to flip it over in the vise. Oh, I'm sorry. I'm not showing you. It's doing its thing. There's the roughing finish up. Oh, there's a mistake. It cut the part free before it's doing this. Because, see, it's the same 3. It's trying to help you. Well, you got that 3/8 end mill. I'm going to cluster those together. And this is why you always want to run this. Probably slow. What just happened? Okay, I'm never sure what's going on. File, save. What did we do wrong? Yeah, we know. Milling job, machining order. Now we go down here. We want gasket surface last. Okay. And now we can simulate one more time. 54 minutes into this show. The time for this simulator is, it seems like I'm waiting a long time. I'll have to go look at other companies, SolidCAM and visibility off. Just go to the end. It's doing its thing. See the slider here, slider, and now it's done. I think it's done. It's still thinking, right? It won't move.
Come on. And it might look like it's attached, but it really isn't. You know, I don't know if well, you won't see because it's mathematics, right? This ends. Is there a breakout area? No, you really can't see. If we even went 1,000th over, we'd be cutting that part. You'd see a gap once we got down into the ball, right? But trust me, the part, when it goes around and does this last profile, the part is cut free. And that was my thinking about not just doing a pocket here and leaving meat here. You know, why face that at first was my thinking. Well, if you just face the pocket area, you know, with a pocket operation, then as you cut this thing loose up here, the part will drop down 50 thousandths, right? That's not good. So I figured now it's flush. The other trick I've seen machinists use, you put double face tape on it here and then flop it over. And it's amazing how well double face tape will hold things. But I don't think, you know, it's not like it's in between in a slot. So 55 minutes and 58 seconds according to the clock on the wall. File, save. It's a demo. Okay, so that's 3D BobCAD CAM. It can get expensive, right? It's a mid-range, $5K price, a little more, a little less, depends on the deal you can work out. I'm done with BobCAD. I'm going to go maybe back and look at fixtures in Visual Mill and maybe some of the 3D and stuff. They came, I think, from the 3D world doing router stuff and carving eagles and wooden platforms. So we'll see how they do. And then the thing I didn't realize till my machinist buddy, Dave, who made that test part, what about HSM Works? I said, well, they're AutoCAD, and I hate Autodesk. I hate them because I had AutoCAD 10, 11, 12, 13, and 14, and I had the AME that they abandoned, and I was treated. He said, well, no, HSM Works, it's owned by Autodesk, but it was I think, Dutch company. It's not a gold partner. That's how I missed it, but it works completely inside SolidWorks. Subscription, $60 a month, 400 maybe, $400 a year or 500 a year. That might, you know, compared to 5,000 up front, that might make sense. So we're going to download that, either get a demo or maybe just buy it because they give you a 30-day money back. That'll be next. So stay tuned. Hope your CAM projects are fun. I will catch you next time. Sportster Paul here. Bye now.